Okay, so we have to start our new chapter named Ellipse. So in this chapter, we will deal with this part. Okay, it is not a big chapter, it is nuclear one. And also you have studied so many parameters twice. In circles, you have studied so many things. The same thing you have studied in parabola. So almost same thing you will study here as well. Ellipse, and then I'll repeat it again in hyperbola as well. Okay, so let's initiate this chapter named ellipse. So as you all know that the definition of conics is locus of a point which is moving in a plane, okay, such that the ratio of its distance from a fixed point, okay, and we call that fixed point as s, and this is the symbol, and then we use a word named focus, okay, and fixed line which is named at directrix. Okay, so this is always constant. You have studied this definition in parabola as well, where we have used ps upon pm. Okay, so ps upon pm, and this thing we call it as eccentricity. Okay, in parabola case eccentricity was 1, but in this case we will have eccentricity as less than 1, means the ratio of distance of the point from focus and directrix will be less than 1, means it can be 1 by 10, 2 by 10, 3 by 10, this way. Okay, it cannot grow more than 10, more means more than 1, or it cannot be 1 either. Okay, now, like, do you remember that, like, what will happen in some cases they will provide you 2-degree curve. So look at this. So x square, then y square, then xy, then x, then y. Okay, so these are the variable of 2-degree curve. Then we used to use a number a, b, c, f, g, h. Okay, and then we have something constant 2, 2, 2. Now this equation will reflect a pair of straight line. When look at this, suppose that you are trying to calculate determinant a, b, c, f, g, h. Focus on the pattern a, b, c, f, g, h. So you have to go through the determinant of this thing. Okay, suppose that the determinant comes out to be 0. Okay, then it is representing pair of straight line. Okay, now suppose that determinant doesn't comes out to be 0, then in this case it may be circle, may be parabola, may be ellipse, may be Okay. Now, when we will have this equation as circle, so if A equals to B equals to 1 and H equals to 0, this thing will represent circle. For parabola, H square must be equal to AB. Eccentricity should be equal to 1. For ellipse, H square should be less than AB. Eccentricity should be less than 1. For hyperbola, H square should be greater than AB and eccentricity should be greater than 1. So under this scenario, we will have different types of conics. I hope till this part you guys are comfortable, and if I'll give you 2-degree curve, you can judge whether it is representing a pair of straight lines, circle, parabola, ellipse or hyperbola. Is that clear? Okay.